Good evening. This is Peter Krushka speaking. This is my presentation on SSH, Secure Shell. And this is for Professor Green's ISA 4220 class. By way of introduction, SSH is an application layer protocol. It provides secure client-server communications. Now what that means is basically it's used for secure logins, file transfer, remote commands and management. It replaces Telnet and FTP. It's very common in Unix environments, but it's somewhat limited in the Windows world. It uses asymmetrical cryptography. If you recall, there are two discrete keys. You have a public key that's distributed by the originator, and a private key is held by the originator. In the Unix world, the command SSH -keygen is the utility that will generate a pair of keys, and the keys are saved in the typically saved in the user's home directory. As I said earlier, SSH is used for remote login, file transfer, and it's going to require two pieces of software. It's going to require a piece of software on the client side and then a daemon process running on the server side. And under client software, I've listed two. I call this PuTTY or PuTTY, and the other is OpenSSH. These are client-level software, and here's an illustration of the home page of the PuTTY software. In the hostname field, you would enter the IP address of the target machine. It's going to port 22. This is for Secure Shell. Down here in this bottom section, one can actually create saved sessions. So if you need multiple machines, you can just select that one, load it, and then open it. I don't show it here, but in the subsequent screen, for example, if one was doing file transfer, excuse me, if one was doing file transfer, there will be another window with a split screen showing the originator's machine and then the target machine for moving files. Here's a simple overview of the handshake process, and I'll get a little bit more in depth in this in a few more slides. But essentially on the left side you've got the client, on the right side you've got the server. The client will initiate the handshake process. It will contact the server and start the process. The server is going to send its public key. The client will then negotiate the parameters to open a secure channel and eventually log into the host operating system. Now, in researching this presentation, I focused on these requests for comments, these RFC documents. There are 5 of them that support SSH. Internal is probably the most complex of these documents. And then the remaining documents discuss transport, user authentication, and connection. And I am not going to discuss SSH-FP in this presentation. So the first document, RFC 4251, essentially discusses how to handle the key exchange. It talks about trust models. There's a local database and then a name to key via certificate authority. The local database is really not recommended because the key management becomes too cumbersome, as opposed to the name to key with the certificate authority, where a public key is used that has been generated, that has been verified by a certificate authority. One thing that keeps coming up in the document was the necessity for really good key management. So that's what the bullet point distribute keys securely is referring to. And in terms of security considerations, we talk about transport, authentication, and connection, which will be discussed in the upcoming slides. And here's the first one, transport, RFC 4253. This is concerned with the connection setup. The connection is going to be over port 22. Historically, ports 21 and port 23 were Telnet and file transfer protocol. When this protocol was being defined, the request went in for port 22 and it was granted. So right between the old ones. The second bullet point on the connection setup refers to the basic syntax of the initial connection comment, where the protocol version, software versions are discussed, and if there's an incompatibility there, the connection is not going to be allowed. And then there's a further discussion of the actual structure of the binary packet, which I'm not going to get into, but essentially it looks like a simple 5-field packet length. Encryption. I can recall studying for the Security Plus exam of trying to remember the different encryption technologies and which one was more current, which one has been compromised. And I think this helps put that in perspective, because now we need to know where these encryptions are used, and if it ever comes to the forefront, to know which one should be disallowed. So in the previous slide we talked about encryption. In this particular slide we're talking about the key exchange. The bullet points 1, 2, and 3 are a highly simplistic explanation of the key exchange process. But essentially, the client and server are each going to start they're each going to pick a random number, and then we're going to do some computations on that number, raise them to a particular modulus exponentially, and then each one is going to send the result to the opposite one. So in bullet point number 1, the client's going to generate a random number. That number will be between 1 and some finite number, and it will compute a value called E. The client will then send that value E to the server. The server will also do something similar. It will compute a value called F and send that to the client. Excuse me, it will keep that because it's going to receive the server's key. The client's going to verify that the server's key really is the host key for the server by using that certificate, the key verified by the certificate authority that we mentioned in a previous slide. Excuse me. Messages. These are the messages that the transport system will use. Transport protocol, disconnect, request service, accept service. The second from the bottom, service number 20, that is the command to exchange keys. Now we get the next one, RFC 4252, which is authentication. Relatively straightforward here, 4 messages, requesting access, and then there's either success or failure, and then a banner message. One thing that came out in the RFC was the client, the server, must use the public key. In the next RFC, 4254, discusses the connection layer. And the connection protocol runs on top of the SSH transport layer. So that was the other RFC that we discussed earlier. Some of the subtopics here are the channel mechanism and interactive sessions. Channel mechanism essentially opens the line of communication between the client and the server, and will define data transfer and then close it. In an interactive session, trying to think about this could be more like a remote login session to a Ubuntu operating system. So via using a secure shell, we would open the session, then request the terminal, and we can start the shell, transfer data, and exit the session. Or transfer data, it may not be transfer data, it may be inputting commands. The RFC also mentioned some security issues over here, and they were to disable various forwarding protocols. So disable agent forwarding, X11 forwarding, and TCP/IP. Then we get to some vulnerabilities. First of all, one of the original versions of SSH, version 1, is compromised and should not be used. A couple of years ago it was discussed that Edward Snowden absconded with some information, and it was released that the CIA could actually intercept communications on the internet. That was discussed here, this Bothan spy, that targets SSH clients, and then this Geyer Falcon targets OpenSSH. The author of SSH looked into this, and he reported in our internet article that although he couldn't see the code, based on the behavior of what he saw. It was conceivable, but he still thinks it's secure, and ultimately that the reason the communications can be intercepted is because of poor implementation of SSH. Right. But that's somewhat historic. What's important for us is man-in-the-middle attacks. Now, SSH is vulnerable to man-in-the-middle attacks. In this illustration, we've got a malicious actor who has positioned himself between a client and the server. And how this is going to operate, there'll be two sessions going on here. The client's going to request a session from the perceived server. However, it's really not connecting with the server, it's connecting with the man in the middle. The man in the middle will mimic the legitimate server and send the client the public key of the man in the middle. Concurrently with this, the man in the middle will also now be opening a session with the server. The man in the middle will be opening a session with the server. He will impersonate the client. The server will then send its public key, to which the man in the middle will intercept that. So now the man in the middle has two sessions going, one with the client and one with the server, and he can intercept the legitimate communications and then capture the data that it needs. And researching this paper, I found a really good video presentation from an educator discussing how to use Kane and Wireshark with regard to a man-in-the-middle attack. And this is the link to that particular session. For hardening practices, again, throughout my research, it kept coming up the importance of good host key management. So the private key should never be left, how shall I say this, unattended, unguarded, be carelessly distributed throughout the system. It should be protected. And then also routers should not use self-signed certificates. And these are the references. You've got my request for comments, the secure shell, and this was the discussion on using Kane. Well, hope you learned something from this. Thank you very much for your attention. Good night.